The most consequential shifts in war don't always announce themselves with explosions.
Sometimes they arrive quietly, altering incentives before anyone fully notices.
By the end of 2025, Ukraine was no longer just trying to fight better, it was trying to fight differently.
Decisions made under strain began redefining how ground is held, how pressure is applied, and how casualties are avoided.
This wasn't about replacing a unit or tactic,
It was about redefining what frontline presence even means in a prolonged industrial-scale conflict.
Ukrainian planners entered 2026 under pressure, but not unprepared.
Their army was tired, ammunition stocks were strained, and allies were cautious. Yet on the front lines, entirely new machines kept appearing. These systems did not just support the infantry anymore, they started taking over jobs once reserved exclusively for humans.
That shift became visible on 12 October 2025 near Kostiantynivka.
That night, Ukrainian forces deployed a Droid TW 12.7 ground robot. The tracked platform carried a 12.7 mm heavy machine gun. Operators positioned it on a road overlooking an expected approach.
A Russian MTLB armoured carrier eventually rolled into that zone.
It carried an assault team meant to break Ukrainian defences. Through the robot's cameras, operators watched the vehicle advancing slowly.
When the MTLB closed the distance, the droid calmly opened fire.
Short, aimed bursts punched through the vehicle's thin side armour. Video from that night shows sparks and penetrations on impact. The crew and embarked troops likely had seconds to react. The damaged carrier lost control and rolled to an abrupt halt. It stopped only a short distance from the low, crouched robot.
The droid then shifted aim towards the rear troop compartment.
Controlled fire into that section appears to have finished surviving occupants. Throughout the engagement, no Ukrainian soldier left protective cover. Commanders later highlighted this event during interviews with journalists.
Many analysts now describe it as one of the first documented ground robot kills.
For Ukraine, it symbolized a move toward unmanned frontline holding. DevDroid, a Ukrainian company, developed the TW 12.7 combat droid. The platform sits within a wider innovation network around Brave One. Its tracked chassis carries the 50 caliber M2 Browning machine gun. Thermal imaging gear lets operators fight in the dark or in bad weather. Anti-jamming measures and redundant links harden the control channels. Operators typically work from several kilometers behind the actual contact line.
What made the droid truly notable was its endurance in combat.
Business Insider and other outlets described one unit's 45-day deployment. For nearly 6 weeks, that single robot supported multiple frontline sectors. It rotated between positions at the request of observation posts. Every 2 days, crews pulled it back for maintenance and rearming. Then it returned to the front, again assuming tasks usually given to infantry squads. Commanders said the droid delivered both fire damage and suppression. Its job was to keep Russian troops pinned and hesitant to advance. Over that period, no Ukrainian soldiers died defending that specific frontage.
For a relatively small machine, the operational effect was disproportionate.
It changed how some Ukrainian units thought about holding ground. Robots could now sit in the most dangerous exposed firing points.
Around the TW 12.7, a broader family of ground robots emerged.
Lighter four-wheeled Lyot vehicles carry 7.62 or 12.7 mm machine guns. They move faster than tracked platforms and reposition between cover points quickly. Units often pair them with drones for coordinated overwatch and fire support. Drone cameras find Russian movement. Robots deliver immediate suppressive bursts. This combination increases lethality without significantly increasing exposed manpower.
Heavier termite platforms prioritize payload and endurance over pure speed.
Analysts report payload figures around 660 pounds across various terrains. Depending on the module, termite can carry weapons, ammunition, or equipment. Medical versions can evacuate wounded from zones too dangerous for medics. Engineering variants transport tools and materials for fortifications or obstacle placement.
By shifting these tasks to robots, Ukraine protects scarce trained specialists.
Murakar sits at the logistics-heavy end of the spectrum. Reports indicate that the payload capacity exceeds £1,100 for resupply missions. A multi-channel communications architecture helps maintain control despite Russian jamming attempts. That resilience matters when electronic warfare saturates the front lines with interference. Murakar hauls ammunition, water, and other supplies under enemy observation. Again, the goal is simple: let machines absorb exposure instead of humans.
Ukrainian officials underscored this priority with significant spending decisions.
In the first quarter of 2025, UGV procurement reportedly reached about $150 million. Analysts note this represented a roughly 60-fold increase year over year. Estimates suggest Ukraine fielded around 15,000 unmanned ground systems in 2025. Projections indicate that the total might approach 30,000 by 2026 if trends continue. Defense experts like Victoria Honcharuk therefore anticipate robot versus robot engagements soon. While ground robots changed defensive tactics, drones transformed the air defense picture. Russia routinely launched Shahed-type loitering munitions against Ukrainian cities and infrastructure. Each Shahed might cost Russia tens of thousands of dollars to produce. Traditional surface-to-air missiles, however, often cost millions per shot.
That asymmetry threatened to turn air defense into a financial trap.
Ukraine needed something cheaper to shoot down cheap drones consistently.
Interceptor drones became one key answer to that challenge.
Ukrainian officials said that by October 2025, interceptor drones achieved a roughly 68% success rate against such targets. These interceptors cost orders of magnitude less than large missiles. Analysts place some interceptor prices in the $3,000 to $5,000 range. That figure remains approximate, but it clearly illustrates the cost advantage. On peak nights, Russia has launched up to around 1,300 drones.
If every oncoming drone required an expensive missile, budgets would collapse.
Interceptor drones instead ram or explode near incoming targets mid-air. They use optical sensors and onboard processing to find and track threats. In many setups, AI handles initial detection and approach. Human operators then assume control for the terminal engagement window.
This human-in-the-loop model balances autonomy with accountability on lethal decisions.
One prominent example is Skyfall's P-1 Sun interceptor drone. Skyfall, known for its Shrike FPV drones, unveiled P-1 Sun internationally in 2025. At the Dubai Air Show 2025, the company publicly unveiled the interceptor. The P-1 Sun uses a modular 3D printed airframe for rapid manufacturing. A company representative said Skyfall already produces thousands of units each month. P-1 Sun is optimized to intercept Shahed-class drones. It approaches from favorable angles, then destroys or disables the target in flight. According to Skyfall statements, this system extends Ukraine's layered air defense. It complements rather than replaces traditional guns and missile batteries.
Because it is cheaper. However, commanders can employ it more freely.
That matters in long wars where cost curves shape strategic choices. TF Industries is another major name in this drone ecosystem. Starting from modest beginnings, it rapidly scaled production during the war. Company information suggests monthly output reaching around 80,000 FPV drones. Annual production value reportedly exceeds $1 billion across various platforms. Within that volume, TAF manufactures strike, reconnaissance, and interceptor variants together. This blend supplies both offensive operations and defensive counter-drone missions. A separate manufacturer, branded as General Cherry, developed the Bullet Interceptor.
In 2025, Ukraine's defense ministry approved codification of this system.
Codification means the drone has been entered into official procurement catalogues and standards. Units can now request it formally and integrate it into regular supply channels. Company representatives discuss moving into serial production for broader fielding. Ukrainian planners have discussed aspirational goals of around 1,000 interceptor launches daily. Behind these systems, Brave One plays a central coordinating role. The government-backed platform links startups, established firms, and military units. Brave One officials describe artificial intelligence as essential for staying competitive. They emphasize that Ukraine faces an opponent with larger manpower and resources. Technology, therefore, becomes a way to rebalance an otherwise uneven fight. More than 200 companies reportedly participate in the Brave One ecosystem. Brave One supports projects across several AI-intensive domains. One area is autonomous target identification for drones and other platforms. Systems learn to recognize military vehicles and distinguish them from civilian objects.
Another area is navigation when GPS signals are jammed or spoofed.
Optical navigation techniques enable drones to follow terrain features such as roads and rivers. Guidance algorithms process imagery faster than a human pilot could manage. Drone swarming is another priority under active development. Instead of controlling one drone per operator, the software coordinates entire groups at once. Drones within a swarm share position and threat data in real time. A single human can direct a large formation toward complex objectives. That scale can overwhelm traditional air defenses designed for fewer targets. It also creates dilemmas for Russian commanders allocating limited interceptors.
To accelerate real battlefield applications, Brave One launched financial competitions.
Selected teams can receive budgets up to about $2.5 million per solution. Priority categories include fully autonomous drones and interceptor guidance modules. Another category focuses on AI tools to counter Russian glide bombs. These bombs cause significant destruction and demand faster defensive responses. Simulation environments allow training AI systems without risking expensive hardware.
In January 2026, Ukraine announced the Brave One data room with Palantir.
This platform aggregates battlefield sensor data under controlled conditions for model training. Engineers can feed real-world imagery and telemetry into their algorithms. The goal is faster iteration on recognition, navigation, and targeting capabilities. Officials also acknowledge that Russia is pursuing its own AI programs. Some reports mention Chinese technical input, helping Russian developers in certain areas. While robots and AI reshape tactical engagements, long-range missiles shift strategy. For years, Ukraine depended heavily on Western-supplied missiles like ATACMS. Those systems are powerful but limited by donor stockpiles and political restrictions.
Ukrainian leaders therefore prioritized the indigenous development of comparable weapons.
In June 2025, reports confirmed progress on the Sapsan ballistic missile project. By December 2025, President Zelensky publicly confirmed Sapsan's combat use.
Sapsan, also known domestically as Hrim or Grom, follows a ballistic flight path. Open sources describe a confirmed range of around 190 miles for current versions. Speeds reportedly exceed Mach 5, faster than many cruise missiles. The warhead mass is said to be around 1,000 pounds, suited for hardened targets. Officials have hinted that production could reach roughly 40 to 50 units monthly. Analysts, however, note that exact quantities remain classified and unverified.
Some Ukrainian statements reference an extended-range domestic variant.
Analysts estimate that the upgraded version could exceed 600 miles in range. If accurate, such missiles could threaten strategic infrastructure deep inside Russia. Russian air defenses would then need to cover a far larger territory. This would stretch systems like S-300 and S-400 much thinner. Military experts argue that properly used ballistic missiles are difficult to intercept consistently. In parallel, the Neptune cruise missile line continued evolving. The original R-360 Neptune was an anti-ship missile from the Luch Design Bureau. In 2022, it gained notoriety after striking the cruiser Moskva. That success proved Ukraine could design effective long-range guided weapons. Engineers then adapted Neptune for land attack. They replaced the maritime radar seeker with GPS-assisted and imaging guidance.
Reports suggest the land attack Neptune reaches roughly 360 kilometers, about 225 miles.
Later, analysts began discussing a long Neptune variant with an extended fuselage. This configuration reportedly carries extra fuel and a heavier warhead. Estimates place the warhead weight at about 550 pounds versus about 330 previously. Ranges for long Neptune are estimated at around 620 miles in some analyses. If realized, that capability would rival or exceed several Western cruise missiles. The Palyonitsia system adds another domestic strike option. Officials describe it as a hybrid between a cruise missile and a long-range one-way drone.
Public statements emphasize relatively low cost compared to imported systems.
Digital Transformation Minister Mikhailo Fedorov has said each unit costs under $1 million. That figure is significantly lower than that of many Western cruise missiles, such as Storm Shadow. Those often cost around $1.5 million or more per missile.
Technical descriptions mention a solid rocket booster for launch. After separation, a turbojet sustains cruise at around 560 miles per hour. Initial range figures hover near 400 miles, with growth potential higher. Payload mass is reported around 220 pounds, guided by GPS and inertial systems. Palianitsia targets include airfields, depots, and infrastructure beyond the front lines. In December 2024, Ukraine confirmed that serial production of the system had begun.
Lithuania contributed about €10 million to support Palianitsia manufacturing.
That funding signaled external confidence in Ukraine's missile industrial base. By late 2025, Zelensky publicly listed Neptune, Long Neptune, Palianitsia, and Sapsan together as domestic capabilities. He declined to specify quantities, citing operational security concerns. The core message was straightforward. Ukraine now fields its own long-range arsenal. It can strike legitimate Russian military targets without requesting permission from allied capitals.
Direct energy weapons represent another front in this technological shift.
In December 2024, Ukrainian authorities announced testing of a laser system called Trizub. The name echoes Ukraine's national trident symbol, linking heritage and innovation. Trizub belongs to the Unmanned Systems Forces rather than classic artillery branches. Its mission is to counter drones and potentially other aerial threats with light. Instead of launching missiles, it focuses energy on a single vulnerable point. Open reports suggest Trizub operates in a similar power class as Western demonstrators. Analysts estimate an output of around 50 kilowatts based on the described effects and ranges. Engagement distances for physical destruction appear to be roughly 1 mile.
At greater ranges, the beam might blind or damage sensors rather than destroy airframes.
Cost per shot is primarily the price of electricity consumed. British officials, for instance, estimate similar lasers cost under £10 per engagement. Ukrainian developers report tests using wreckage from downed Shahed drones. In demonstrations, the laser burned holes through structural material within seconds at several hundred feet. These results support claims that such systems can disable small drones under favourable conditions.
However, experts stress that physics places strict limits on performance.
Moist air, fog, rain, smoke, or dust all absorb and scatter the laser beam. Thermal blooming can spread the beam as superheated air distorts the path. Power generation and cooling add further challenges for field deployment. A 50 kilowatt class laser requires robust power sources like generators or high-capacity batteries. The system also needs cooling to protect optics and electronics from heat damage. Because of these constraints, Trizub is not a complete replacement for missiles.
Instead, it could supplement them, handling cheaper drones under suitable weather.
Ukraine has not disclosed how many Trizub units exist or where they are located. As of early 2026, several trends are visible despite ongoing secrecy. Ukraine increasingly uses unmanned ground vehicles to hold sectors and move supplies. These robots reduce soldiers' exposure while maintaining or increasing firepower. Interceptor drones and experimental lasers gradually blunt Russia's drone saturation tactics. Domestic ballistic and cruise missiles lengthen Ukraine's reach far beyond the front line. AI systems knit these technologies together, shortening the time from detection to strike.
For Russia, these developments erode several of the initial advantages it gained in 2022.
Artillery superiority matters less when small robots contest intersections for weeks. Drone swarms and interceptors complicate reliance on cheap Shahed attacks. Rear-area airfields and depots find themselves within reach of new Ukrainian missiles. Soviet-era doctrines struggle to keep pace with continuously evolving autonomous systems. For Ukraine, this technological momentum offers a way to resist and gradually reshape the battlefield.
What is unfolding in Ukraine is not a preview of some distant future.
It is a real-time adaptation under fire, shaped by scarcity, urgency, and survival. Machines are not replacing soldiers so much as redefining where humans must still stand. Every robot on a road, every interceptor in the sky, and every algorithm shortening a kill chain reflects a deeper shift in how modern wars are fought. The battlefield is no longer just a place of massed forces. It is an ecosystem of systems learning, adjusting, and enduring.
And once that threshold is crossed, war does not go back to what it was.
If you want to understand how modern warfare is actually changing, not through headlines, but through systems, decisions, and real battlefield evidence, consider subscribing. This channel breaks down conflicts the way planners and analysts study them, focusing on what matters long after the news cycle moves on.